What would you say if I told you that there is a frozen galaxy drifting through the universe as a living fossil? For billions of years, the James Webb Telescope has now discovered such a living galaxy fossil. This galaxy has not formed new stars for billions of years, yet it still exists. What is this astronomical wonder really about? A fossil galaxy is a galaxy that consists mainly of older stars and has not formed any new stars for billions of years. In astronomy, fossil galaxies are considered to be remnants from the early days of the universe, and they provide our scientists with fascinating insight into the developmental history of galaxies and into the developments in the early universe. Usually, such fascinating fossil galaxies are found at the center of huge galaxy clusters. There, they may have been left over from merging galaxy clusters. Nevertheless, these peculiar galaxies raise questions. Why did some galaxies freeze and virtually stop growing very early after their formation, and why are these galaxies still active in their own way? These galaxies have hardly changed their shape and composition since the early days of the universe, making them witnesses to an epoch about which we know very little. The James Webb Project should finally provide us with valuable insights into the earliest history of the universe. Since the launch of the telescope, we have been surprised again and again. The telescope is showing us scientific wonders by the dozen, and the list of cosmic curiosities is getting longer and longer. We still don't know why and how galaxies formed, and we know very little about why galaxies have been clustering together more and more as the universe has evolved. Research is currently focusing on very old and distant galaxies that date back to the early days of the universe in order to finally understand the true evolution of matter. The fossil galaxy that the James Webb Telescope has now discovered is another special case in the list of discoveries. The galaxy formed extremely early and extremely well and widely for evolutionary steps that take billions of years for other galaxies. This galaxy took only a fraction of that time. This explosion of star formation is what astronomers and cosmologists call a starburst. In a short period, the galaxy produced billions of stars, forming a perfect elliptical spiral shape. Then, star formation in the galaxy practically froze, and since then, this galaxy has hardly changed. It's considered a scientific miracle how these beautiful galaxies can continue to exist despite the stagnation in star formation. It's probably due to the distribution of gases and the effect of dark matter and dark energy. That a galaxy becomes a fossil so early in the evolution of the universe is definitely unusual, however. The effects of dark matter and dark energy on the formation of visible matter and galaxies are still insufficiently understood for scientists to be able to make clear statements about the true nature and dynamics within fossil galaxies. The galaxy fossil NGC 1277 in the Perseus Galaxy Cluster. Isn't it incredible that with instruments like the James Webb Space Telescope, we will be able to analyze objects millions and even billions of light years away from us? Thanks to its unique infrared spectrometers, the James Webb Space Telescope can capture light in wavelengths hidden from the human eye. Webb collects the faintest traces of light and then converts them into images we can perceive. Thanks to this technology, scientists can now see through clouds of cosmic dust for the first time. Cosmic dust is a common phenomenon, and ultimately, all matter and all galaxies in the universe are made up of dust and gases. The dust in space can be so dense that telescopes like Hubble often fail. Because of impenetrable walls of dust, what was hidden behind them remained in the dark for science. Infrared light can penetrate dust clouds, and so Webb can also turn these light trails into images. This is how we now see areas of the universe that remained hidden from Hubble's eyes. Hubble was already a milestone in space exploration, and the telescope was able to discover the galaxy NGC 1277, which is about 220 million light-years away from Earth, despite its limitations. This galaxy is another living fossil from the early epochs of the universe. The stars in NGC 1277 are all very old. Imagine a galaxy in which there are almost only ancient stars, a composition of beauty, form, and functionality that has only undergone no significant further development for billions of years. The vast majority of stars in this galaxy are about 10 to 12 billion years old, and as it stands, these stars were far from reaching the end of their lives. By comparison, our Sun probably has a total lifetime of only about 9 billion years. It's strange that this galaxy has produced a large number of extremely long-lived stars. Scientists would love to know what processes led to galaxies developing into beautiful and stable structures in double quick time, and they would like to know whether all galaxies in the young universe developed in this way. The starburst theory is currently the most popular way of explaining the unusually old and well-developed galaxies that Webb discovered. Explosive developments could be the reason why 200 or 300 million years after the Big Bang, thousands of beautiful and very advanced galaxies were already in existence in the cosmos. Unlike the fossil galaxies, normal galaxies have undergone development since the early days of the universe. Stars were born. Stars perished. Galaxies migrated and merged with others, thus repeatedly changing their appearance and shape. NGC 1277, on the other hand, has not formed any new stars for billions of years. The galaxy consists almost exclusively of old, metal-poor stars, as were typical of the early universe. Until now, however, researchers thought that these old stars of the first populations did not have a particularly long lifespan. In the galaxy NGC 1277, on the other hand, these early light and metal-poor stars are apparently very stable and reach an almost incredible age. Some previously unknown mechanism could have frozen the processes within the galaxy. Understanding exactly what this mechanism is would be of the utmost importance to us. A force that first explodes entire galaxies into growth, then freezes them and allows them to persist in their once acquired form could indicate a previously unknown magnitude in the universe. Interestingly, NGC 1277 contains an extremely massive black hole at its center, which makes up about 14% of the galaxy's total mass. This mass fraction is already unusually high, and there are other peculiarities around this black hole. Normally, this black hole would have to devour quite a bit of the galaxy's matter over the course of billions of years. The galaxy would therefore shrink, especially if it does not form new stars. So far, it is not known whether the mechanisms of the black hole in this galaxy have somehow come to a standstill. NGC 1277 is also not found at the center of a gigantic galaxy cluster. Unlike other fossil galaxies, this galaxy is largely isolated in a section of the universe where there are very few galaxies overall. A galaxy with an Einstein ring was discovered by JWST. Have you ever heard of an Einstein ring? These astronomical objects were long a purely hypothetical assumption. It was basically the mathematical genius Albert Einstein who predicted the existence of these objects, but no one had seen one for almost 100 years. Einstein rings are, simply put, special cases of gravitational lensing. However, they do not form a magnifying glass-like arc, but a perfect ring. The James Webb Space Telescope has now discovered a galaxy that actually has one of these objects, known as SDSS J12262149. It is another of those special cases in science, and again, we have the extraordinary capabilities of the new telescope to thank for the discovery. Only James Webb's fine sensors were able to capture the faint emissions from this physical wonder in the depths of space. The Einstein ring around SDSS J12262149 was created by the distortion of light emitted by the galaxy. An intervening galaxy cluster has stretched and distorted the light through its mass in such a way that it is stretched into a ring shape. In this case, the stretching is not only an exciting physical effect, it also causes a significant magnification of objects behind it. Thus, an Einstein ring has a similar effect to a gravitational lens. Both effects allow researchers to see objects that are very far away and practically invisible to our eyes without these effects. The first ever Einstein ring to be spotted was in the galaxy cluster AL 370. This cluster even offers one of the most spectacular examples of a complete Einstein ring ever observed. This effect allowed astronomers to examine the distant galaxy in detail and gather information about its structure and the rate of star formation within the galaxy. Beyond this purely fantastic aspect, the Einstein ring around AL 370 is another perfect example of how the general theory of relativity works in practice and continues to enable new astronomical discoveries. Thanks to the gravitational lensing effect, astronomers have been able to see many other objects in the universe. The galaxy GNZ 11 is one such object, one of the oldest and most distant galaxies ever discovered. It has gone down in the history books of astronomy. It's located about 13.4 billion light-years away and dates back to a time only about 400 million years after the Big Bang. With the help of the lens effect, the light from this galaxy was amplified, allowing astronomers to gain valuable insights into its structure and composition. Thanks to gravitational lensing, even the Hubble Space Telescope made this discovery at a time when scientists thought the telescope had long since reached the limits of its power.